Welcome to Spelling. Today we're going to learn about algebraic expressions, and we'll start by major definition of terms. Major definitions of terms. When you talk about algebraic expression, so you're first going to define what algebraic expression is. So you say that algebraic expression is a combination of variables constants and operations. When we talk about operations, we talk about addition, subtraction, multiplication, and division. So those are the operations that we're going to deal with. Again, we can start defining what a variable is. For example, we're asked what a variable is. We see that a variable is a symbol. And most of the time, we usually use a letter. That represents an unknown value. When you talk about a variable, for example, if we have this algebraic expression, x plus 5, e.g., x plus 5, we'll say that whatever you don't know the value of, we say that x is the what? X is going to be x is a variable. Then the other term we're going to define is a constant. What a constant is. We say that a constant is a fixed value that does not change. For example, if we have the same example in x plus 5, we'll say that 5 now is going to be the what? 5 is a constant. Then we can also define what a term is. Okay, let's first start by a coefficient. What is a coefficient? Let's define what a coefficient is. Coefficient, we say that is the what? Is the number multiplying a variable. E.g., when we have e.g. in 4x, see, we already have the variable here, which is the unknown for us, but tuko na nini? We still have 4 here. So we usually call the 4 the what? 4 is the coefficient. Again, we can define what terms are. Usually say that a term, what are terms? Say that a single is a single part of an expression separated by the operation. So it can either be what? It can either be plus, it can either be minus, or it can also be multiplication. So that is what we call the terms. For example, if we have this, if you have 3x plus 4, e.g., 3x plus 4, the terms in this algebraic expression are going to be what? Are going to be 3x and what? And 4. So those are the terms in the algebraic expression that is having 3x plus 4. From there, we can now go to formation of real life algebraic expressions. How can we be able to form algebraic expression? So that is going to be our next part. That is formation of. We have defined what an algebraic expression is. We have said that it's a combination of variables, constants, and operations. And then a variable is a symbol, usually a letter that represents an unknown value. For example, we have said when we have x plus 5, x is the what? X is the variable. Then what is a constant? We said that a constant is a fixed value that does not change. For example, if we have in x plus 5, we say that 5 is a what? 5 is a constant. Then we go to what a coefficient is. A coefficient, we have said that it's the number multiplying a variable. E.g., when we have 4x, the number that is multiplying our variable, which is x, that is what we call the coefficient. Then the terms is a single part of an expression separated by either addition or subtraction. E.g., when we have 3x plus 4, we have two terms here. We have 3x, and we also have what? And we also have 4. So from there, we can go to the next part. That is formation of algebraic expressions. So when you're told to form algebraic expression, what does it mean? If you're given, for example here, let's have examples. And our first example is going to be, if you're told a number is increased by 5, then you're told form an algebraic expression. So a number, remember this is a number that we don't know. So this is going to be our variable. And we have said we can use letters to represent variables. So we'll talk about our number being x. Then you have been told that a number is increased by 5. To increase means that it is x plus 5. And thus our algebraic expression is now what? X plus 5. A number is increased by 5. Here we can have this second example, B, that is telling us that Ravi has some apples. Then you're told he buys 4 more. So if you're told that he buys 4 more, what does it mean? It means we have some apples. Remember, these are apples that we don't know how many are there. They are our unknown, or they are the variable. So let's talk of the apples. Let's say we can use A. Now that you're talking about the apples, we can talk about A. Then we are told that Ravi bought how many more? Bought 4 more. So he buys 4 more. So that means it is going to be what? It is going to be A plus 4. Buying more means you have added to whatever that he had. Again, we can also have one on subtraction. For example, if you're told in a classroom, you're told in a classroom there, sorry, it is in a classroom of 30 learners. There are M boys. Form an expression for the number of girls. What does it mean? This means that in that classroom, there is having how many boys? There is having 30 boys. So we're going to talk about the learners. If we add the boys plus the girls, you're going to have what? You're going to have that, because the class has got 30 learners. But again, what have we been given? We have already been given that they are M boys. So you're going to talk about what? M plus girls gives us 30. Then are we going to remain with the girls here? We are going to take M, that is the number of boys, to the other side. So it is going to be girls. If we want to know the number of girls in that class, it is going to be 30 minus M. So the expression that is showing us the number of girls in that class is what? 30 minus, that is the total number of learners, subtract what? Subtract the number of boys in that class. So that is what you're going to have. Then we can go to the other part, that is addition and subtraction of algebraic expressions. So that is formation of algebraic expressions involving what? Involving addition and subtraction. So that is the next part that we're going to go to. So let's get there. Formation of algebraic expressions involving addition and subtraction. So when you talk about these are some of them. That is whatever that we have already done, as much as formation of algebraic expressions is concerned. So it's just but the same thing, because for example, if you're given here, if you have been told to have examples here, such that you have been told that in A, what have you been given? You have been told, see an example here. So if you are told that today we have A, sum of a number and 8. So remember, the number that you're talking about is unknown for us. So we will talk about of the number. Let's even call it n. So it is going to be n plus what? N plus 8. So we can also have B, a question that is telling us that kilo is 7 kg lighter, lighter than Masawe. Then you're told form an algebraic expression for kilos weight if Masawe's, Masawe's weight or weighs WKG. So what is the question asking us? It is telling us that kilo is 7 kg lighter. So if we are to use numbers for this, for example, let's talk about kilo here and Masawe. We are told that kilo is 7 kg lighter than Masawe. So that means if we talk about Masawe being 50 kg and kilo is 7 kg lighter, so that means 7 kg lighter than Masawe. So that means kilo is what? Kilo is 43. How have you gotten 43 kg? This means it is 50 minus 43, so that we get the same kg. So now we want to form this algebraic expression here. Remember, Masawe is what? Remember, Masawe is WKG. But kilo is what? Kilo is 7 kg lighter. So if we want to know kilo's weight, we'll talk about kilo's weight being what? Kilo's weight is going to be W, which is Masawe's weight, minus what? Minus 7. And remember, these are what? These are kg. So that is how we are going to determine the age of. That is how we are going to determine the age of not the age, but the age of kilo. Again, we can also have algebraic expressions involving. So the next thing you're going to learn about is forming algebraic expressions involving multiplication and division. So when you talk about algebraic expressions involving multiplication and division, so you have already dealt with algebraic expressions that involves what? That involves addition and subtraction. So let's see what is going to happen. So if you are told, for example, if you're given, let's have examples. You're told just as simple as that a number is multiplied by 9 from an algebraic expression for this. So if you are told that a number, remember this is a number that we don't know. So this is our variable. So we'll talk about what? We can talk about x. Or let me not use yes, now that it is multiplication. Let me use m times. A number is multiplied by 9. So it is m times 9. But remember, we said that when we are writing algebraic expression, we usually start. This now is going to be our what? Is going to be our coefficient. So this is the same as 9 times now the number. Remember, our number is m. such that this is going to give us what? This is going to give us 9m. So that is what you're going to have. Then we can go to example B. Example B is telling us that form, that is B, form an algebraic expression for the number of days in n weeks. So we have been told here to form an algebraic expression for the number of days in n weeks. So one thing that we need to know is a week has got how many days? So we know that 1 week is equals to 7 days. But now what are we talking about? You're talking about n weeks. So there are weeks that we don't know how many they are. So if, for example, there were 3 weeks, we would have known it is 3 times 7. It is 5 weeks, we would have known it is 5 times 7. But now we don't know. We don't know the number of weeks. So this is simply going to be what? This is simply going to be n times 7. This is the number of weeks and the number of days. Remember, this one can also be written as 7 times n. Then this is going to give us what? 7. 7n as our 7n is our algebraic expression. I hope that it is clear up to that point. Then we have this that is telling us, so we have this C is telling us John has 40 sweets to be shared among his children. So we don't know how many children they are, but John is having 40 sweets and he wants to divide to share those sweets among his children. So if we are to form an algebraic expression for this, let me add my page just a little bit. So what are we going to have? This means that it is going to be, we're talking about 40 sweets. For example, let's use a number before we go to the variable. If you have 40 sweets and you have 2 children, that means each one of them is going to get 20. But now we are talking about what? We are talking about 40 sweets, but we don't know the number of what? The number of children. So we form to be shared. So if you are told, if the question was form an algebraic expression to show the number of sweets each child receives. So this is going to be the way it is going to be. So that means we have what? That means we have the 40 sweets to be shared amongst what? X children. So it's the 40 sweets to be shared among X children. So this is the number of what? This is the number of sweets that each child is going to receive according to the number of the children. From there, you can also be told, can also have, let me see what else you can have here. You have, you have another example here that is telling us that a number is divided by 3, D. So you're told that a number is divided by 3. Then you're told to do what? Form an algebraic expression to show this. So what does it mean? We talk about a number being divided by 3. Remember, this is a number that we don't know. So we are going to call it x or over 3, x divided by 3. Well, basically, we can still express it x divided by 3, a number which is a variable we don't know, divided by 3. So that is what you're going to have. I want us to do one more example that is on the application part of whatever that you're doing, that is on algebraic expressions. So what have we been told? We've been told, let me see, one application question that we can do. So we are told to do this. We are told, have the exercise here. We are told a boy, number 1, a boy has X chocolates, gets 2x more, and then 3 extra. Extra chocolates. Then you're told form an algebraic expression for these. So what are we going to have? You've been told that a boy has X chocolates, gets 2x more, and then 3 extra chocolates. So you're going to add this for these. So if you want to know the total, you want to know the total number of chocolates that the boy has. So it is going to be, the total is going to be x plus 2x plus what? Plus 3 more. So that is going to be what? That is going to be our algebraic expression. Again, we can also have this one more, being told simplify. Then you have been told, you have been given 3x plus 5x plus 2. Remember, for you to add on these, you need to ensure that what you're adding is that they are like terms. For example, here we have 3x and 5x, and you also have the constant what? The constant 2. So remember this one, in this one we usually call them like terms. That is because this is x and this one is x. So this means it is possible for us to add 3x plus 5x to get what? To get 8x. But we also have what? But we also have 2 there. So that is going to be our final answer. You can also have another one here. Let's call that A. Then on B, just on the same, if you're given 2x plus 3y plus 5x, what are you going to do? Remember, we have said you can only add like terms. So for this case, the like terms is x and x. This one is not the same as x's. So that means that one is just going to remain the same way it is. And thus we're going to have 2x plus 5x. These are the like terms plus 3y, which is going to be what? Which is going to be 7x plus 3y. And that is going to be our answer. And that brings us to the end of our lesson today. I hope that you have been able to understand. That is algebraic expressions. So let's meet once again. Have yourself a great evening. Bye-bye. Thank you for taking your time to watch this lesson.